Hello and welcome to another episode of Math with Mrs. Wilson. Today we are covering section 8.6, solving radical equations. By the end of this section, you will be able to solve radical equations with two radicals, and use radicals in applications. An equation in which a variable is in the radicand of a radical expression is called a radical equation. Let's look at the steps to solving radical equations. So we have the square root of 3m plus 2 minus 5 equals 0. The first step, and always the most important step, is that you want to isolate the radical on one side of the equation. Remember that. All right, so the first thing that we're going to do is add 5 to both sides. And that leaves us with the square root of 3m plus 2, make sure the radical goes all the way over, is equal to 0 plus 5. All right, the 5's canceled, we have the radical on one side now. Step 2 is to raise both sides of the equation to the power of the index. In this case, it's a square root, so the index is 2, which means we're going to take both sides and we're going to square it. From there, we get this equation. The radical goes away because the square cancels it, and then 5 squared is 25. Now we just have to solve this. Subtract 2 from both sides. And we get 23 is equal to 3m. And then we divide by 3, so we get m equals 23 thirds. Then we have to check that because sometimes we might have an erroneous solution. So to check our solution, we want to go back to the very original equation. So I'm going to copy the original equation, but where the m is, I'm going to put parentheses. We're going to plug in our solution there. Oops. Not equals minus 5 equals 0. So we plug in our solution, which is 23 over 3. And we just solve it from there. So the 3's end up canceling, right? So 3 times 23 over 3 is just 23. 23 plus 2 is 25. The square root of 25 is 5. And 5 minus 5 does equal 0. So our solution checks. So that's how we know it's a true solution. Now we have a couple try it problems for you to try at the whiteboards in your groups. If you worked these out on your own at home, you can check your answers and the steps. And if you did them on the board, you should have gotten x equals 1, and the work to check it is shown, and you should have gotten x equals 5/2. Again, the work is there, and it does check. Turn your page when you are ready. If an equation has a radical with an even index equal to a negative number, that equation will have no solution because it won't be real. It won't be a real number. For example, solving this next one, we would subtract 5 from both sides. And so the radical 2r minus 3 equals negative 5. no, the square root, even if I squared both sides, it should not equal a negative number, because when we take the square root of something, it does not equal a negative. So we would say no solution. All right, in your groups, you can just turn and talk for the try it, and then we'll come back and discuss it. Sometimes we get a binomial square. So in this case, we need to draw on a few of our math skills. The first thing we want to do always is to isolate the radical. So we're going to get x minus 2, and I'm going to subtract 2 on the other side, so that's going to be x minus 2. Notice how there wasn't a 0 on that side. So we're not equaling a negative per se. Now we're going to square both sides. When we do that, the square root sign goes away, so we have x minus 2. And when we square a binomial, and it's the same thing, like we're squaring the binomial, that's going to be a perfect square trinomial. So on our side, we can just write PST as a reminder that that's going to be a squared plus or minus, depending on the sign, 2ab plus b squared. So we're going to take the x, we're going to square it. Then it's a minus, so minus 2a is x, b is 2, and then 2 squared is 4, so plus 4. That's the formula for a perfect square trinomial. Now we want 0 on one side, but first I'm going to simplify. So just bring down the x minus 2 for now. X squared, I'm going to simplify the middle term to negative 4x plus 4. And then I'm going to get 0 on one side, so I'm going to add 2, and at the same time, maybe I'll put that in red. At the same time, I'm going to subtract the x to get it to cancel. So this side cancels, leaving us with 0 on that side. X squared minus 5x plus 6. All right, now this should look familiar as something that we can factor. So think about what our factors would be. What are factors of 6? Remember our x method, factors of 6 that add up to negative 5. Well, 2 times 3 is 6. If I make them both negative, they still equal positive 6, but when we add them together, we get negative 5. So these are our factors: x minus 2, x minus 3, and this equals 0. Remembering our 0 product, so I'm just going to put that over here, 0 product rule. That is going to say that each factor can equal 0. And solving, we get x equals 2 and x equals 3. And I just want to make sure that if I were to plug those into my radical, that I don't get a negative number, because I can't take the square root of a negative number. 2 minus 2 is 0, that's fine. Square root of 0 is 0. 3 minus 2 is 1, square root of 1 is 1. So both of these check as answers. All right. In your groups, you can do the try it. And if you had a question on that example, please call me over. I'd be happy to explain the example further. But right now, in your groups, do the try it. Take a moment to check your answer. And moving on to the next concept, when the index of the radical is 3, we cube both sides to remove the radical. Because notice the cube and the cube root are opposites, so then we're just left with a. So basically we solve this the same way, except that we are cubing both sides. Let's start with subtracting 8. And we get the cube root of 4x minus 3 equals 5 minus 8 is negative 3. It's okay that it's a negative because we're taking a cube root. Remember, if it's odd, we don't need to worry about it if it's negative. If the index is even, then we have issues. So negative 3 cubed is negative 27. And this cancels the cube root. So we just have 4x minus 3. Now we're just solving it like a regular equation. So we add 3 to both sides. We get negative 24. And then we divide by 4, x equals negative 6. And you can plug that in to check. 4 times negative 6 is negative 24. Minus 3 is negative 27. Take the cube root of that. You get negative 3. Negative 3 plus 8 equals 5. I just checked it in my head, but it does check. I'm going to pause the video and have you work on the next try it problem. Go ahead and check your answer for that try it problem. Sometimes an equation will contain rational exponents instead of a radical. So let's solve this equation. We're going to want to get not the radical, but the exponential expression by itself, like isolated. So the first thing I'll do is add 2 to both sides. Bring everything else down. Okay. Divide by 2. I think it's really important that you show each step. So I should put what I'm doing in red. So now I'm going to divide by 2 so that this 2 cancels. And then we're left with 10x plus 10 to the 1/4 is equal to 2. Now to undo the 1/4, I'm going to raise both sides to the 4th power. Doing that will turn the exponent into a 1. So I'm going to raise this to the 4th power. It cancels this exponent because now it changes it to an exponent of 1. So I have to raise the other side to the 4th power. From here, I'm just left with 10x plus 10, 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now it's just a simple 6th grade equation. So we're going to subtract 10, both sides, this cancels. You can get 10x equals 6. Divide both sides by 10, and then we'll reduce our answer. That reduces to 3/5. And you could plug it in and check it, but I'm pretty confident that we did that correctly. I'm going to pause the video and have you do the try it in your groups at the whiteboard. And check your answer and then turn the page when you're ready. As we saw when we were looking at the binomial squares, sometimes the solution of a radical equation results in 2 algebraic solutions, but one of them may be an extraneous solution. So let's take a look at this example of when that is true. Let's isolate the radical. So we're going to add m to both sides and subtract 3 from both sides. So that gives us the square root of m plus 9. These canceled. is equal to m minus 3. We're going to square both sides of the equation. So this side is going to be just m plus 9, and the other side will be m minus 3 squared. Simplify and then solve. So we're going to use our perfect square trinomial method. Remember the a squared. In this case, it'll be minus 2ab plus b squared. That's our PST. Okay, so we'll get m plus 9 equals m squared minus 2. I'm going to put the 3 next and then the m. So it would be BA instead of AB, plus 3 squared, which is 9. So this is m plus 9. I'm just going to simplify and then solve it. M squared minus 6m plus 9. So we didn't completely solve it because in this next step it says it's a quadratic equation, so get 0 on one side. Notice how there's a 9 on each side, so that 9 could just cancel. If I'm subtracting 9 and I'm subtracting m, then I get the 0 on one side. And then there's 0 here, right? Like the 9's canceled. It says factor the right side. The only way to factor that is to take out the GCF, which is m. Using the 0 product property, I'm going to take each factor equal to 0. I'm going to solve that. Obviously, m equals 0 and m equals 7. To check it, I just plug those each in. So we're going to get the square root. Instead of m, I'm going to put parentheses plus 9 minus m. This is the original equation. Plus 3 equals 0. I have to do that twice because I need to do it for 0 and for 7. So I'm going to rewrite the exact same thing again. But smaller because I'm out of space. And then in each of those parentheses, I'm going to plug in our solution. So 0, and in the other one, I'm plugging in 7. Now I'm checking to see if it's correct. So 0 plus 9 is 9. The square root of 9 is 3. 3 minus 0 is 0 plus 3 equals 0. Uh-oh. Either I made a mistake or that's not true. Hopefully the other one is true. 9 plus 7 is 16. The square root of 16 is 4. Minus 7 plus 3 equals 0. Oh, thank goodness, that one checks because that is true. 4 plus 3 is 7. 7 minus 7 is 0. That one checks. So the solution is m equals 7 and m equals 0 is extraneous. All right, so that's how you decide if it's extraneous or not. Go ahead and try this problem. Just try it in your groups, and then we'll come back to check our answers. Let's solve radical equations with like radicals. If both sides of the equation have a fourth root, you can just raise each side to the fourth power and the radicals go away. So this is just 2x minus 4 equals 3x plus 13. Now we just solve this as a regular equation. So I'm going to get variables on on one side by subtracting 2x. That cancels. Then we have negative 4 equals x plus 13. I'm going to subtract 13 on both sides to isolate x. And that becomes negative 17 equals x. And you could check that if you'd like to see if it's true on both sides. Let's see, negative 17 times 2 is negative 34. Negative 34 minus 4 is negative 38. We're taking the fourth root. Well, that actually is not real. But let me just see if it equals the other side. 3 times 17, 51, negative 51 plus 13. Yeah, that's also negative 38. But that's not real. So I just want to say that that's not real. All right. Go ahead and try it. And this one you don't have to worry about if your solution gives you a negative radical because it's a cubed root. So try that in your groups and then we'll come back. All right. Sometimes we have to keep solving the radical, and let me show you what I mean by that. In this case, we are still going to square both sides. So when I square the left side, I get the square root of x plus 2 squared. And when I square the right side, I'm just left with x plus 16. Now I'm going to simplify this further by doing my PST, perfect square trinomial, which is a squared plus 2ab plus b squared. So the first term is the square root of x. If I square the square root of x, I just get x plus 2 times, I'm going to put the 2 here and then the square root of x, plus b squared, b is 2, so b squared, 2 squared is 4. Then we have x plus 16. From here, I'm just going to simplify. X plus 4 square roots of x plus 4 equals x plus 16. The x's on both sides cancel. Then I could divide everything right now by 4 and just get the square root of x plus 1 equals 4. No, I think I can't do that. Hold on. I don't want to do that. It actually doesn't hurt to divide everything by 4, but instead I'm just going to solve it as I would normally. 4 square roots of x, if I subtract 4, I get 12. If I divide by 4, I get the square root of x equals 3. Now I'm just going to square both sides. So 3 squared is 9. X equals 9. And if you plug that in, it works out just fine. It's kind of cool if you do want to plug it in and check, but I just checked it mentally and it works. All right, at your boards, go do the try it. So that we have enough time, we're actually going to skip these two problems. And in this application problem, my equation editor messed this up a little bit. So I want you to take this equation and instead write t equals the square root of h over 4. And that equation is discussing on a falling object on Earth. And it is if the object is dropped from a height of each feet, the time in seconds it'll take to reach the ground is found by using this formula. Okay, so T is in seconds, and H is the height in feet. Okay, Marisa dropped her sunglasses from a bridge 400 feet above a river. Use the formula to find how many seconds it took for the sunglasses to reach the river. So we would use T equals, that's a pretty high bridge, the square root of 400, because that's the height, over 4. And then we would just solve that. Dogs. We have, we're going to simplify the 400 into, well, actually, we can take the square root of 400. It's just 20, because 20 times 20 is 400. So that is equal to 20 over 4, which is equal to 5 seconds. In your groups, go ahead and do the next try it problem. But again, my equation editor messed it up just a little bit. It's a little bit easier to fix on this one. We have this radical. I just need you to extend it over the whole expression. So it's S equals 24D. S is the speed and D is the distance. Okay, you can check your answers for that try it problem. And then write a summary. You can talk to your partner and give a sentence and get a sentence. Give one, get one. And then get your homework started for the 8.6, homework number 8.6, and please write the numbers at the top so you can check them off as you go. Thank you for doing math with Mrs. Wilson.